हेलो एंड वेलकम बैक एवरीवन टू जेनिथ एकेडमी ऑनलाइन। मैं हूं शहाना और आज हम कर रहे हैं सिमिलैरिटी का पार्ट 2 फॉर आईसीएसई क्लास 10। पिछले पार्ट में हमने देखा था कि सिमिलर फिगर्स क्या होते हैं, उसके बाद हमने समझा था कि सिमिलर ट्राइंगल्स क्या होते हैं और उसकी प्रॉपर्टीज़, और मोस्ट इंपॉर्टेंट हमने पढ़ा था बीपीटी क्या होता है, दैट इज़ बेसिक प्रोपोर्शनैलिटी थ्योरम क्या होता है। अब आज हम पढ़ेंगे कि अगर कोई भी दो सिमिलर ट्राइंगल्स है तो उनके एरिया का रिलेशन क्या है, प्लस उसके रिलेटेड कुछ प्रॉपर्टीज़, और हम कुछ और क्वेश्चंस भी सॉल्व करेंगे बीपीटी और एरिया ऑफ सिमिलर ट्राइंगल्स के रिलेटेड। सो लेट्स स्टार्ट। पहले देखते हैं रिलेशन बिटवीन द एरियाज ऑफ टू ट्राइंगल्स। तो द थ्योरम इज द एरियाज ऑफ टू सिमिलर ट्राइंगल्स आर प्रोपोर्शनल टू द स्क्वायर्स on their corresponding sides। हम एग्जाम्पल लेते हैं, जैसे कि ये दो ट्राइंगल्स है, ट्राइंगल ABC और ट्राइंगल DEF। ये दोनों ट्राइंगल्स सिमिलर हैं। ये दोनों ट्राइंगल सिमिलर क्यों है? बिकॉज एंगल BAC एंड एंगल EDF प्लस एंगल B इज इक्वल्स टू एंगल E एंड एंगल C इज इक्वल्स टू एंगल F। So by angles postulate, these two triangles are similar. Now what we need to prove? Area of these two similar triangles, that is area of triangle ABC and area of triangle DEF, are proportional to the squares on their corresponding sides. Let's see how can we write this? Areas of two similar triangles, that is area of triangle ABC upon area of triangle DEF are proportional to the squares on their corresponding sides. Now पिछले सेशन में हमने देखा था कि हम corresponding sides कैसे लिखेंगे सिमिलर ट्राइंगल्स की। तो इसकी सिमिलर साइड्स होंगी AB upon DE, and here it is saying they are proportional to the squares on the corresponding sides. So this implies this is AB square upon DE square. Similarly, second side will be BC square upon EF square, and the third side is AC square upon DF square. Let us see how can we prove this. Let's draw an altitude AM and DN on both the triangles. Now for both area of a triangle we know is half base into height. So this altitude will be the height of the triangle. So let's see how can we write this. Let's draw those two triangles again. This is ABC. And this is the altitude we have drawn, AM. This is the other triangle, DEF, and the altitude we drawn was DN. Now let's see what will be area of triangle ABC. Half base into height. So half base is BC and height is this altitude AM. So it will be half into base, that is BC, into height, which is AM. Area of triangle DEF will be equal to half base is what? EF into, and what is the height? DN. Now when we take this ratio, area of triangle ABC upon area of triangle DEF, so when we divide this, now half and half gets cancelled. What we will get? BC upon EF into AM upon DN. So when we need to prove that it is area of triangle ABC upon area of triangle DEF should be equal to the squares of their corresponding side. So here it should be BC square upon EF square. Now how can we write AM upon DN equal to BC upon EF? If we take these two triangles, AMB, triangle AMB, and this triangle DNE. This is 90 degrees. This we know because we have drawn an altitude on this triangle, and since triangle ABC and triangle DEF were similar in the previous slide we have seen, because of angle B and angle E were equal, they both are equal. So by angle postulate we can prove that triangle AMB and triangle DNE are similar. In triangle AMB and triangle DNE, this is given to us, and hence triangle AMB is similar to triangle DNE. AA similarity, or by AA postulate. Now since triangle AMB and similar to triangle DNE, its sides will be proportional, that is AM upon DN will be equal to MB upon NE will be equal to AB upon DE. The other thing we know is this triangle ABC and triangle DEF are similar. It was given to us in previous slide. So if they are similar, their sides are also proportional. So let's write its sides. AB upon DE, BC upon EF, is equal to AC upon DF. Now what we get here, BC upon EF is equal to AB upon DE, and AB upon DE is equal to AM upon DN. Right? Mark this. This as 1, this as 2, and this as 3. By 1, 2 and 3, what we will get? And AB upon D is also equal to AM upon DN, which implies this. So this implies BC upon EF should be equal to AM upon DN. We can put this in this equation, BC upon EF into here it will become BC upon DF. So ultimately it will become BC square upon EF square. Let's write it. Area of triangle ABC upon area of triangle DEF is equals to BC upon EF into, instead of AM upon DN, from here I can write AM upon DN is equals to BC upon EF into BC upon EF, which is equal to BC square upon EF square. Now since these sides are proportional and hence instead of BC upon EF I can write AB upon DE whole square also and AC upon DF whole square also will be equal. So area of triangle ABC upon area of triangle DEF will be equal to AB upon AB square upon DE square, BC square upon EF square or AC square upon DF square, and hence proved. So this is what the theorem says and this is what we actually need to remember. Area of triangle ABC upon area of triangle DEF will be proportional to the squares of their sides, that is AB square upon DE square, BC square upon EF square and AC square upon DF square. Let's first solve a question so that this theorem will be clear to us. In the given figure, this DE is parallel to BC. DE is parallel to BC. Prove that triangle ADE and triangle ABC are similar. Triangle ADE and triangle ABC are similar. So, in triangle ADE and triangle ABC, see DE is parallel to BC. So, this implies the corresponding angles, angle ADE and angle ABC will be equal. Angle ADE is equals to angle ABC. Why? Because they are corresponding angles. Either we can take angle A is common, or what we can do, since D is parallel to BC and angle D is equals to angle B, by the same property, angle AED is also equal to angle ACB because they are also corresponding angles. By the same theorem, by the same property, corresponding angles. So hence, triangle ADE is similar to triangle ABC by angle similarity. Hence proved. It is given that this AD is equal to half BD. We have been given the ratio AD is equals to half BD. If we can write this like this: AD, shifting BD on the other side of the equal sign, AD upon BD is equals to half. So the ratio of AD upon BD, that is AD upon BD, should be 1/2. Now we need to calculate DE, that is this length, if BC is given to us as 4.5 centimeters. We know that triangle ADE is similar to triangle ABC. This we have proved in the first part. So from first, their sides will be proportional. So AD upon AB will be equal to DE upon BC will be equal to AE upon this AC. Now we need to calculate DE. BC is given to us. Let's take these two sides. DE we need to calculate, BC is given to us. We have the ratio of AD upon BD and not AD upon AB. Please note this carefully that we have the ratio of AD upon BD. So how can we convert it into AD upon AB? See, AD upon BD is equals to 1 by 2. AB is BD plus AD. So instead of BD here, if we write AD plus BD, so what this ratio will become? 1 upon 1 plus 2, because it is AD plus BD. So we'll add this ratio 1 upon 1 plus 2. What AD plus BD is? AB. So AD upon AB will be actually 1 by 3. So now this whole term we know is 1 by 3. BC we know. So DE is easy to calculate. Instead of AD upon AB, let's write 1 by 3. DE we need to find, and BC is 4.5. So now just we need to cross multiply. So our DE will be equal to 4.5 divided by 3, which will be equal to 1.5 centimeters. Now what our third part says, find area of triangle ADE upon area of triangle ABC. This is the theorem we read. Area of two similar triangles. They are in what ratio? Area of triangle ADE upon area of triangle ABC should be of the ratio of corresponding sides. So corresponding sides are AD upon AB square. Now AD upon AB we know as 1 by 3. So this is 1 by 3 whole square, which is actually equal to 1 by 9, and hence area of triangle ADE upon area of triangle ABC is equals to 1 by 9. Now the other part is saying area of triangle ADE upon area of trapezium. This trapezium BCED. Area of triangle ADE and area of triangle ABC. How can we find the ratio of this BCED trapezium? So it's easy. Area of triangle ADE we need in the numerator. In the denominator we need the trapezium. So if we look at this whole figure, area of triangle ABC, if we subtract area of triangle ADE from it, we'll get area of triangle BCED. So area of triangle ABC minus area of triangle ADE. Instead of trapezium, we can write this area of triangle ABC minus area of triangle ADE. Now what was area of triangle AD upon area of triangle ABC? It was 1 by 9. So it will be 1 upon 9 minus 1. This is area of triangle ABC, that is 9, minus area of triangle ADE, 9 minus 1. So this will be equal to 1 by 8. Hence our area of triangle ADE upon area of trapezium BCED is equal to 1 upon 9 minus 1 is equals to 1 upon 8. So this is our answer. Some points to remember. There are 2 points to remember and they are very important. Median divides the triangle into 2 triangles of equal areas. Whenever a median is drawn, say suppose in this figure ABC, we have drawn a median from A and it is AD is the median. Now whenever a median is drawn, we know it will bisect this side into equal parts, but here it is saying whenever a median divides the triangle, it will divide it into 2 triangles of equal areas. This implies this area and this area will be equal, or they both are equal to half into area of triangle ABC. if many triangles have the common vertex and their bases are along the same straight line. Let's see this example. Here we have one triangle. This is ABD. ADE is the second triangle. AEC is the third triangle, and this whole triangle ABC. And also ABC is also a triangle. Now there are other triangles also. So if we see, there are many triangles originating from a single vertex, that is A, and they are along the same base, that is here, along the same straight line. Base is not the same, they are along their bases, that is in triangle ABD, its base is BD, which is along the same straight line, this whole straight line BC. The ratio between their areas, whenever this kind of triangle we have, the ratio between their areas is equal to the ratio between the lengths of their bases. Ratio between their areas. For suppose, let's take area of triangle ABE. Area of triangle ABE upon area of triangle ADC. This triangle. Now these both triangles are originating from the vertex A, and their bases are along the same straight line, that is BC. So the area will be equal to the ratio, the length of their bases. Here it is not square. Please remember, it is not the square. It is just the length of their bases, that is BE upon this DC. BE upon DC. It is not square. Please keep this in mind. Area of triangle ABD. This triangle ABD and triangle ABC. This whole triangle ABC. Triangle ABC and triangle ABD. They are originating from the same vertex and their bases are along the same line. So what are their bases? BD and BC. So their area will be equal to the length of their bases, the ratio of the length of their bases. Now it's time to move on to solving some important advanced questions. First important thing we need to keep in mind is, whenever we have been given a diagram and whatever is given in the question, हमको पहले ये ट्राई करना चाहिए कि जो भी गिवन इन्फॉर्मेशन है और जो भी हमारे पास डायग्राम में गिवन है, हम उसको इंटरप्रेट करें और उसके हिसाब से जो भी हमें प्रूव करना है या जो फाइंड आउट करना है, हम वो कंक्लूजन रीच कर सके. अब ये कैसे करना है? लेट्स सी. इन द फॉलोइंग डायग्राम, लाइन्स L, M and N are parallel to each other. These three lines L, M, N are parallel to each other. There are two transversals P and Q which intersect the parallel lines at points A, B, C and P, Q, R as shown. ये दो transversals हैं जो इन तीनों parallel lines को intersect कर रही हैं A, B, C और P, Q, R points पे. Now we need to prove that AB upon BC is equals to PQ upon QR. हमने BPT में पढ़ा था कि कोई भी ट्राइंगल कि अगर एक साइड के पैरेलल कोई दूसरी लाइन ड्रॉ की जाती है तो वो अदर टू साइड्स को इस रेशियो में डिवाइड करती है. अब यहाँ पे ट्राइंगल नहीं है तो हम एक लाइन ड्रॉ करके यहाँ पे एक इमेजिनरी लाइन ड्रॉ करके हम एक ट्राइंगल बना सकते हैं. कैसे? या तो आप A से R ज्वाइन करिए या P से P C को ज्वाइन करिए, इट विल नॉट मैटर. सो इधर हमने आज A R को ज्वाइन किया है. ये यहाँ पे इस पॉइंट को लेट्स मार्क इट एज X. अब ये ट्राइंगल देखते हैं हम, ट्राइंगल A R और इसके पैरेलल लाइन है B X. नाउ BX is parallel to CR, so by BPT we know AB upon BC will be equal to AX upon XR. Similarly, हम दूसरे ट्राइंगल में देखेंगे. अब दूसरा ट्राइंगल हो सकता है ये, ट्राइंगल APR, ट्राइंगल APR. अब इसमें हम इसे यहां ड्रॉ कर लेते हैं. ट्राइंगल APR और XQ is parallel to AP. XQ is parallel to AP. Since this is parallel, so it will divide this in the ratio. So PQ upon QR will be equal to AX upon XR. Let's mark this as 1 and this is 2. So we have got these two equations. So by 1 and 2, AB upon BC is equals to PQ upon QR, because they are equal to the same ratio AX upon XR. So we can write this AB upon BC is equals to PQ upon QR, and hence proved. In the following figure, AD and CE are medians of triangle ABC. DF is drawn parallel to CE. DF is drawn parallel to CE. Prove that EF is equals to FB. EF is equal to FB. We need to prove. What we have been given is AD and CE are medians. AD and CE are medians. This implies that BC is divided into equal parts, and similarly AB is also divided into two equal parts. DF is drawn parallel to CE. This DF is drawn parallel to CE. We need to prove EF is equals to FB. If we see this triangle, triangle BEC, and DF is drawn parallel to CE. So this is one triangle. Let's take this triangle BEC. What we have, DF is parallel to EC. So by BPT, what we can conclude, that this BF upon FE should be equal to this BD upon CD. BF upon FE. See, FD is parallel to CE. So this BF upon FE should be equal to BD upon CD. The other two sides by BPT. Since AD is a median, it is dividing BC into two equal parts. So BD and CD are in the ratio 1:1. So BF upon FE is equals to 1:1, or this implies BF is equal to FE. Hence proved EF is equals to FB. We can write it like this: EF is equals to FB. This is proved. Now let's move on to the second part. Second part is we need to prove AG is to GD. This AG is to GD equal to 2:1. Now let's find another triangle here. This triangle triangle AFD, in triangle AFD, so this line GE will be parallel to DF, because we have been given that DF is drawn parallel to CE. So this part of line CE, that is GE, will also be parallel to DF. GE is parallel to DF. So by BPT, what we will get? AE upon EF is equal to AG upon GD. Now what we need? AG upon GD to be equal to 2:1. Let's see what is AE upon EF. AE upon EF. Now here this AE and BE. AE is to BE is equal to 1:1, because C is the median and E will be the midpoint of AB. So AE is equals to BE. Now what is BE? BE is equal to BF plus FE, and BF and FE are equal. We have proved this in part 1. So instead of BF we can write it as 2FE, that is FE plus FE, 2FE. So BF, our BE is equals to 2FE. So this implies BE is equals to 2FE. So here in AE upon EF, now AE is again equal to BE. So BE is equals to 2EF. We can write this here also. So instead of AE, we will put 2FE upon FE. I have written EF as FE. It is one and the same thing. So this will be the ratio 2/1. Now since AE upon EF is equals to 2/1, and by BPT we have proven that AE upon EF is equals to AG upon GD. So this implies AG upon GD will be equal to 2/1, or the ratio 2:1. Now in triangle ABC, AP is to PB is equal to 2:3. PO is given parallel to BC. This PO is parallel to side BC and is extended to Q. Now this PO is a parallel line which is extended to Q, so that CQ is parallel to AB. CQ is parallel to AB. Now what we need to find? Area of triangle APO is the ratio of area of triangle APO and area of triangle ABC. This APO and triangle ABC. So first let's see triangle APO and triangle ABC. APO और ABC, PO is parallel to BC हमको दे रखा है. हमको पता है इन दोनों ट्राइंगल को हम सिमिलर कैसे प्रूव कर सकते हैं, ये हमने पिछले क्वेश्चंस में किया है. सेम वे, सिंस PO is parallel to BC, this angle APO and angle ABC will be equal. एंगल A कॉमन दे रखा है, या फिर हम एंगल AOP और एंगल ACB भी कॉरस्पॉन्डिंग एंगल्स ले सकते हैं. सो बाय एंगल सिमिलैरिटी what we will get, triangle APO is similar to triangle ABC. Since it is similar, what will be its area? Area of triangle, the ratio of their areas will be equal to the squares of their corresponding sides, the ratio of the squares of their corresponding sides. So, AP, first side is AP square upon AB square. Here AP is to PB is given to us as 2:3. Is to PB is given to us as 2:3. This is AP and this is PB. So how can we get AB? AP upon, if we want AB, so what we will write? PB plus AP. So this will be 2 upon 2 plus 3, which is equal to 2 upon 5. So this implies AP upon AB is equals to 2 upon 5. So here the ratio of area of triangle AP upon area of triangle ABC is equals to AP square upon AB square. We know AP upon AB, we'll just put the values. So this will be equal to 4 upon 25. The second part is asking area of triangle APO upon area of triangle CQO. This triangle APO and CQO, let's just see this part. If we see this angle AOP and COQ, they are vertically opposite angle, so they both will be equal. Also, this AB, this whole AB is parallel to CQ, and there is a transversal, this AC is a transversal for the parallel lines. So this angle A and this angle C, they are the alternate interior angles made by the transversal on the parallel lines. So they both will be equal. So this implies angle BAC and angle ACQ will be equal. Angle AOP is equal to angle COQ by the reason of vertically opposite angles. And angle PAO is equal to, by the property alternate interior angles. So by AA similarity, what we will get? Triangle APO, triangle APO is similar to triangle CQO. CQO. Now since these triangles are similar, the ratio of their areas will be equal to the squares of the ratio of their corresponding sides. Area of triangle APO upon area of triangle CQO will be equal to, let's take this side, AP upon CQ square. Either we can take this side or the other side is PO square upon QO square, or AO square upon CO square. Now here AP is to PB we know. So AO upon OC will be same by first we know that AO upon AC will be equal to 2:3. this was parallel to this. So AP upon PB will be equal to AO upon OC by BPT theorem. This we have seen in first part. AO is to OC is equals to 2 is to 3. So we'll take this side, AO square upon CO square is equal to 2 whole square upon 3 whole square, which is equals to 4 by 9. So area of triangle APO upon area of triangle CQO is equal to 4 by 9. Hence answer. Let's move on to our last question. Given AB is parallel to DE and BC is parallel to EF, prove that AD upon DG is equals to CF upon FG. AB is parallel to DE. This AB is parallel to DE. Now AB is parallel to DE. So if we see in this triangle, AB is parallel to DE. So by BPT we can get the ratios. So in triangle AGB, DE is parallel to AB. So by BPT, AD upon DG will be equal to BE upon EG. Also, we have been given BC is parallel to EF. This BC is parallel to EF. So, if we see this triangle here, EF is parallel to BC given to us. So let's take triangle BGC. Triangle BGC. EF is parallel to BC. So by BPT, what we will get? BE upon EG is equals to CF upon FG. Let's mark this as 2 and this as 1. So now from 1 and 2, BE and EG is common. BE and EG is equal to AD upon DG and it's also equal to CF upon FG. So by this we can say that AD upon DG is equal to CF upon FG, hence proved. Now we also need to prove that triangle DFG is similar to triangle ACG. DFG. This triangle is similar to triangle ACG. ACG. DFG and triangle ACG, what we have? Now from first we know that AD upon DG is equals to CF upon FG. AD upon DG is equals to CF upon FG. So by converse of BPT, what we can write? DF is parallel to AC. DF is parallel to AC. So this implies triangle this DFG and triangle ACG will be similar. We have proven in other previous questions also. This angle D and this angle A, angle GDF and angle GAC will be equal because they are corresponding angles, and this angle G is common, or we can take angle GFD and angle GCA as equal by the same property corresponding angles. Let's write it. Hence, proved. Now, our last and final question. Given ABCD is a rhombus. This ABCD is a rhombus. DPR and CBR are straight lines. This line DPR and the other line is CBR. They are joining at points R. Now we need to prove that DP into CR is equals to DC into PR. Now let's see. We know that sides are in the ratio for similar triangles. Now what triangle we need to take? How can we interpret this from the given question? First interpret this information. ABCD is a rhombus. तो ये सुनते ही हमारे दिमाग में फर्स्ट चीज क्या आती है? rhombus की प्रॉपर्टी. ABCD is a rhombus. तो ABCD यानी AB और AD ये एडजेसेंट साइड्स है तो ये इक्वल होगी, या फिर BC और CD ये दोनों एडजेसेंट साइड्स है तो ये इक्वल होगी. आवर सेकेंड इंफॉर्मेशन इज DPR और CBR स्ट्रेट लाइन्स है. अब हमको प्रूव क्या करना है? DP इंटू CR इज इक्वल्स टू DC इंटू PR. हम देखते हैं कि हम इनसे कुछ रेशियो बना सकते हैं क्या? DP अपॉन DC करेंगे अगर DP और DC, तो ये एक ही ट्राइंगल की साइड्स हो रही हैं. एक ट्राइंगल की साइड्स हम नहीं लेते हैं, दो ट्राइंगल की साइड्स होनी चाहिए हमारे पास रेशियो में, तो ये वर्क नहीं करेगा. तो DP अपॉन अगर PR करते हैं तो DP अपॉन PR, तो DP इस ट्राइंगल की साइड हो गई और PR इस ट्राइंगल की साइड हो गई, तो हमें ट्राइंगल्स मिल गए इससे. सी दिस इज DP for this triangle and PR is this side, so we can take this triangle. अब ये दो ट्राइंगल्स हाईलाइट हो गए हैं तो हमारे लिए फाइंड आउट करना इजी. तो रेशियो होगा DP अपॉन PR इज इक्वल्स टू DP अपॉन PR इज इक्वल्स टू DC अपॉन CR. ये सिर्फ हमने इक्वल टू के साइन चेंजेस किए हैं. इस इक्वेशन को हमने इस फॉर्म में लिखा है. अब DP अपॉन PR ये अगर हम कैसे ला सकते हैं? अगर हम ये ट्राइंगल DPA और ट्राइंगल PRC को सिमिलर प्रूव कर दे तो लेट्स टेक ट्राइंगल DPA एंड ट्राइंगल RPC. This angle P, this DPA and RPC will be equal because this is vertically opposite angles. So angle DPA is equal to angle RPC. The reason is vertically opposite angles. Now, see, this is a rhombus, so the opposite sides AD and BC are parallel. This BC is extended to R, so this is also parallel. There are two transversals. Either we can take DR or we can take AC. So if we take these AC as a transversal, this angle and this angle, that is angle DAP and angle PCR, angle DAP is equal to angle PCR will be equal. Why? Because these both lines are parallel and AC is the transversal, so alternate interior angles are equal. So alternate angles, for the reason they are equal, so this implies by AA similarity triangle DPA is similar to triangle RPC. So now we can write the sides, their sides will be proportional. So DP upon RP is equals to PA upon PC is equals to DA upon RC. Now DP upon PR we got. We need to prove that it is equal to DC upon CR. We have CR here, but here it is DA for one of the sides. Since this is a rhombus, ABCD is a rhombus given to us, so adjacent sides are equal. So instead of DA, we can write DC. So now proving is easier. Since ABCD is a rhombus, so therefore DA is equal to DC. So this implies here in this equation it will be DP upon RP, we can write it as PR. It is one and the same thing, equal to, instead of DA we will write DC upon RC or CR, and hence proved. So this is how we solve the questions. Solving is always easier. What we need to do, जब भी हमें कोई क्वेश्चन और डायग्राम दे रखा है तो क्वेश्चन में जो जो भी इंफॉर्मेशन है वो हम लिख लेंगे, और साथ ही डायग्राम से हम क्या क्या इंटरप्रेट कर सकते हैं उन्हीं सब इंफॉर्मेशन को लेके हम ये कंक्लूजन निकाल देते हैं. सॉल्विंग हमेशा ईजियर होता है, बस हमको इंफॉर्मेशन को इंटरप्रेट करना अच्छे से इम्पॉर्टेंट है. दिस वॉज ऑल फॉर आवर टुडेज सेशन. वी हैव कंप्लीटेड द थ्योरम्स फॉर सिमिलैरिटी. अब हम करेंगे हमारे थर्ड वीडियो में सिमिलैरिटी की एप्लीकेशन मैप्स और मॉडल्स के ऊपर, वो समझेंगे हम, और साथ ही उसके रिलेटेड हम क्वेश्चंस करेंगे. सो इफ़ यू हैवेंट येट चेकड आउट द प्रीवियस वीडियो, आई रिक्वेस्ट यू टू प्लीज़ चेक इट आउट एंड ऑल्सो सॉल्व दीज सम्स. अगर आपको कोई भी डाउट है तो प्लीज़ कमेंट सेक्शन में हमें लिख कर बताइए. अगर आपने इस वीडियो को लाइक किया है तो प्लीज़ डू गिव इट अ थम्स अप, और अगर अभी तक आपने सब्सक्राइब नहीं किया है तो प्लीज़ डू सब्सक्राइब. थैंक यू एंड कीप द लर्निंग ऑन.